You pull out your phone, open the map, and within seconds, a blue dot shows exactly where you are. Anywhere on Earth. Accurate to within a few meters. You use it every day, but how does it actually work? No cell towers. No internet connection required. Just satellites, math, and one of the most elegant systems ever built. This is how GPS actually works. The basic concept. GPS stands for Global Positioning System. It's a network of satellites orbiting Earth that constantly broadcast their location and the exact time. Your phone receives those signals. And using nothing but the time it took for those signals to reach you, it calculates exactly where you are. No communication back to the satellites. No data sent. Your phone is just listening and doing math. Here's how. The satellites. There are 31 GPS satellites orbiting Earth at approximately 12,500 miles altitude, about halfway to the moon. Each satellite orbits the planet twice per day. They're arranged in 6 orbital planes, ensuring that at any point on Earth, at any time, you can see at least 4 satellites. And you need at least 4. Every satellite carries an atomic clock, accurate to within nanoseconds. It constantly broadcasts 2 pieces of information: its exact position in space, and the exact time the signal was sent. Your phone receives that signal, checks the timestamp, calculates how long the signal took to travel. Radio waves travel at the speed of light, 186,000 miles per second. If the signal took 1/10 of a second to reach you, you're 18,600 miles from that satellite. But that doesn't tell you where you are. It tells you you're somewhere on a sphere with a radius of 18,600 miles. You need more satellites. Trilateration. When your phone receives signals from a second satellite, it calculates the distance to that satellite. Now you're somewhere on 2 intersecting spheres. The intersection of 2 spheres is a circle. When your phone receives a signal from a third satellite, the intersection of 3 spheres is 2 points. 1 point in space, and 1 point that's either underground or in space, which your phone eliminates. Now you know exactly where you are. Latitude, longitude, and altitude. That's trilateration. You're measuring distances, not angles. The 4th satellite. But there's a problem. This system depends on incredibly precise timing. If your phone's clock is off by even 1,000th of a second, your position could be off by hundreds of miles. Satellites have atomic clocks. Your phone doesn't. That's why you need a 4th satellite. The 4th satellite provides a timing correction. Your phone uses it to synchronize its clock with the atomic clocks in space. It's solving for 4 unknowns: latitude, longitude, altitude, and time. With 4 satellites, your phone calculates all 4 simultaneously. The challenges. GPS signals are weak. By the time they travel 12,500 miles from space, they're incredibly faint. That's why GPS doesn't work well indoors. Buildings block the signal. Urban canyons create multipath errors where signals bounce off structures. And GPS can be jammed or spoofed. It's not encrypted for civilian use. The reality. GPS was developed by the US Department of Defense, launched in the 1970s and 1980s, fully operational in 1995. Originally, the military degraded the civilian signal deliberately, accurate only to within 100 meters. In 2000, President Clinton turned off that degradation. Civilian GPS became accurate to within 5 to 10 meters. That decision enabled every navigation app, every rideshare service, every location-based technology we use today. The system is free to use. No subscription, no license. The US government maintains it. Russia has GLONASS. Europe has Galileo. Trilateration. Radio waves traveling at the speed of light, atomic clocks in space, and math. That's how GPS actually works.